Okay, welcome once again. I sincerely appreciate you for constantly coming to our videos. I love the way you watch our videos anytime we drop it here in this channel. Sincerely, I want to present to you another techniques of solving a problem in your solar system. Of course, I've been following a series and I've been dropping them per time and how you can be able to rectify every challenge that comes in your solar system. I treated how I solved a problem of no outputs in my previous video and it was amazing. You need to watch it if you've not done that. Then if you have watched it, of course you know that there are a lot of lessons that you need to get from that video. And today I discovered a way of solving another particular problem. What is that problem? Of course, everyone should understand that per time when you load your system, there's what we call overload problem. I observed the system today and what I saw was, oh, it was incredible. When you talk of solar system, my inverter was doing overload and I couldn't solve it. All of a sudden, the client invited me. Of course, you ask, am I the one that is using it? How do I know that it was an overload issue? That's why we are professionals, and from our experiences, we teach you how you can overcome those challenges as an installer and as a user, how you can be able to avoid such issues. Got into the system, we observed that the system is actually rated 5,000 watts precisely, that is 5 kVA in quotes. Yes, I said 5 kVA in quote because most often what we see in the market is not actually the current rating or the actual rating of the system. Perhaps this system is 4,000 watts that they rated 5 kVA. So coming to the system, I discovered that it cannot handle the required load. And whenever these appliances are turned on, the system automatically shuts down. So observing this system, I know what could have been the cause and why such things are happening. So follow me today and see how this issue of overload problem is being rectified. You need to see, when you get to the system, the first thing you have to observe is look at the system critically. Ask the user how he has been using it, because the best person to tell you what happened per time is the user. If not, you spend longer time doing your troubleshooting, trying to find out what happened. So when we got to this place, the user said what happened to the system is actually the problem of not bringing outputs. Oh, okay, I listened and I did not waste my time to find out why the output is not coming. I just looked at the system and found out that there was no output. First, I turned off the breaker, switched off the circuit breakers that were controlling both the output and the input. Then I relaxed a bit and went further to ask him what happened that made this system to go off, because I know it had been serving you for a period of time. So why all of a sudden it stopped bringing output? That was when he opened up and told me that there were appliances that this system used to handle before now, but as a result of his carelessness, he turned on some appliances that made the system to go off and wrote overload circuits. Everything about the system shut down. So I went ahead. Funny enough, it is very simple. All you just need to do is to watch the video, share, comment, like, and ensure that we build a community of bringing out solutions to solar world problem. So moving ahead, I turn on the system again, then switch off the entire thing. That is first thing. You should follow these procedures as I'm mentioning them. These techniques are very technical and it takes a technical ideas and reasoning for you to understand it. When I got to the system, I discovered that all he said is true. There's no output. Then I solved it. Now, after solving the output, the inverter displayed 220 volts output. I'm seeing it on the screen, but I didn't go ahead to power the house. Do you know why? I need to find out what caused the circuit to do overloading. Then I discover what causes short circuits in between the system. So I discovered it I now isolated the problem. By isolating the problem, I now made the system function proper. But first, what do you need to do at the first place? You need to observe the system. After your observation, make sure you troubleshoot. From your troubleshooting, trace the fault to a particular section where it is coming from. Now, in so doing, I practically switched off the entire system, switched off all the appliances in the house, then started afresh by powering my solar system, and the moment the inverter was switched on, it became normal. Then I started by powering my system one after the other. First, I switched on the bulb. Look at how I did it. You see, I turn it on and the whole system is on. Now, I now found out that this is not the problem or the fault or what causes the short circuit. Now, I moved ahead. I got here. You see my TV. I turned it on. Get this. So when this is turned on, I discovered that this was not the problem. I came here. My switch is actually here. So I turned it on. The switch is on. So now my fridge is now working. I made sure that it is working. Bring your hand down to see the vapor is coming out, telling you that it is on, and this is the indicator as a proof that it is on. So when I got to this point, the head TV and also powered the fan. You see, taking time to do them one after the other. I got here. I powered this fan too. You see the fan is working now. So when I got turned on the bulb, you can see the bulb that they are all working. Now after I isolated that, we come back, and I now consider the load. I still maintain, leave it in one, don't worry. Just leave it in one. I maintain my load. You can see the voltage, the input voltage, and the load is around 3000 and something watts. So I have to come back, consider my battery. I checked this. See what I'm generating. This is 1 kilowatt, 900 to 1 kilowatts is generated. So this is what we actually got from this. You see, this is on, and this fan is also on. I have to equally tell you why I took you to all these places for you to see the appliances that are on, and not just that they are on. I discovered what actually causes the problem. First, when the load is higher than your inverter system, what we experience is that the inverter will automatically go off. Whenever you observe that your system is displaying overload circuits, the first thing that should come to your mind is the appliances that are on. Like you have 1 kVA and you are loading it with a load of 1000 watts. It is actually wrong. In engineering, there's what we call tolerance, and we have permissible tolerance as well. When you look at the system, first thing that should come to your mind is this system is 5000 watts, rated 5000 watts. It is required of you not to load it exactly 5000 watts. Why? You need to give the system a space to operate. So when you have a load of 4000 watts, we recommend 5000 to 6000 watts for you. That is, we recommend 5 kVA to 6.2 kVA and above. Why? So you can be able to handle the load comfortably without affecting the internal components that are doing the job, especially when you're using IGBT or even MOSFETs, that when they drive, you see that the load rely on them to function. So looking at that point, you should know that whenever your system displays overload, you have to consider what you have turned on. Some will even have inverter and turn on their fridge, turn on their AC, and all these things will be working properly. So what was the cause of this overload that we observed? Today I want to tell you, and I will show you what happened. What are the secrets? They have AC, they have fridge, they have TV, they have different forms of fans, that is different capacities, 20 inches, 16 inches, 26 inches. They are all loaded in this solar system. But suddenly the user forgot to do what we call load separation, and he mistakenly turned on what? The water heater, and that was what brought overload circuit to the inverter system. So the system had to shut off automatically to prove to you that what has been given to me is higher than the capacity I can handle. And that is what happened. I will show you the system and equally show you the... When we got here, I discovered that this young man was on when the inverter is already using around 4,500 watts load. Then when they added this is equivalent to 1,500 watts. So when they added it by turning on this switch, the moment this switch was turned on and this guy peaked a bit, the system went off automatically. So the lesson to learn in the whole of this process is that you shouldn't overload your system, that is your inverter system, because every inverter has a capacity and maximum load that handles. So the moment it exceeds that, what you bring in is called overload to the system. And when that happens, the system automatically shut down. So that is what happened to this system. And I am glad you watched through, and sincerely speaking, I would love you to see most of my videos as I continue to bring you every solution to the problem of solar energy. I remain myself, Rexsam, the solar doctor. Thank you for watching our video. See you in my next video. Thank you.